Excuse me. Pardon me. No, not up there. I'm down here. Yep. Hello. I am a scientist, and I've come to improve your situation just a bit. See that fire over there? Have you ever really wondered what the flames are from that fire? I mean, look at all of those colors, and you feel that heat. It's hot, right? Well, gee, it must be torture being around all these flames and not knowing what they are. Here, take a look at this cupcake. Do you see the flame on top of this delicious-looking cupcake? You do like cupcakes, don't you? Let's take a closer look, shall we? Fantastic! If we look at the flame on top of this cupcake, we first notice a few things, like all the colors. At the bottom, we have this bluish color, and the top is more yellow, orange, and reddish. Also, the flame is hot. Why is it so flaming hot? Well, to answer these questions, you need to know something very important. You see, everything is made up of tiny things called atoms. And these things are the building blocks that make up everything. And they're really small. Smaller, smaller, even smaller. Hey, look, you can't even see them, they're so small. Exactly. Anything you can think of is made up of atoms. Yep, this air conditioner is made up of atoms. This delicious popsicle is made up of atoms. This ice water is made up of atoms. Everything is made up of billions and billions of atoms. Now this candle and flame, well, they are made up of 3 kinds of atoms: carbon, hydrogen, and oxygen. The carbon and the hydrogen are locked together to form a solid wax and wick. The oxygen is a gas all around us. Normally, the oxygen doesn't do much to the candle. It just bounces off of the surface, not doing any real damage. But when we add heat, the oxygen atoms go bananas, and they shake the wax like crazy until finally, with enough force, they snap apart. They leave the candle as a gas, where they mix with the oxygen. Uh-oh, I smell trouble. Well, the fancy science word for all of this is pyrolysis. It's the first thing that needs to happen to get a flame. It's when the fuel turns to a gas. Now, let's see what happens when these hot gases combine.
Ladies and gentlemen, in this corner, he was once a solid. Now he's a gas. He is the fuel from the wax. And in this corner, not one, but 2 groups of oxygen. Ready, react!
Anytime certain atoms get hit hard enough, they spit out blue light. And because there are lots of atoms getting hit hard and lots of atoms spitting out blue light, we get a blue flame. Here comes another science word. Ready? Chemiluminescence. I know, it's a big one. One more time. Chemiluminescence. It's when atoms shine light when they rearrange. It's why flames are blue. Now, the blue light is not hot. Wait! But the blue flame is really hot. So if the blue light is not the hot part, then what does make a flame so hot? Well, remember our fuel atoms and our oxygen atoms? They rearrange to make new stuff like water and carbon dioxide. And as they rearrange, they snap together. And with each, the new things shake like crazy. So when the rearranging is done, we have lots of new stuff, all shaking really fast. If we put something close to those raging atoms, well, those atoms begin to shake like crazy too, like the atoms in our finger, and that's heat. This is called oxidation. It's when the oxygen atoms combine with other atoms to make new stuff. It's why flames are so hot. All right then, why are most flames yellow, orange, and red? Well, remember our first reaction? We had 1 group of fuel atoms and 2 groups of oxygen. They made a flame that was very hot and only blue. But watch what happens if there's not enough oxygen and we take some away.
Ladies and gentlemen, what happens when there's not enough oxygen?
What's this? A single carbon atom left all alone? It's okay, because all of his leftover carbon friends come to join him, and they form large black particles we call soot. Okay, they're not so large. They're so small we can't even see them. But to a single atom, they are enormous.
Enormous!
I know what you're thinking. How do black particles make yellow flames? Well, let me show you. But first, I need something big and black, like this pitchfork, for example. Excuse me, sir. Your evilness? Could you please place your pitchfork into those scorching flames? Thank you. Big black objects are like sponges that soak up heat. They have to get rid of this energy, so they spit it out by glowing. The hotter they get, the more brightly they glow. Now, the same thing happens with our soot particles. They drink in the heat from all of those hot atoms, and they glow brighter and brighter until they look like this. And because there are millions and millions of soot particles all glowing hot, we get this yellow flame. This is called incandescence. It's when the soot particles glow because they're hot. It's the reason why flames are yellow. Well, that's it. That's what flames are. I mean, who knew cupcakes could be so much fun? Remember, first the fuel loses mass and turns to a gas. Before the next change is through, atoms shine blue. When the process is complete, it gives off heat. Extra carbon will glow red, orange, and yellow. Hey, those are just like the lyrics from that really awesome song about flames. You know, the one that goes, "The fuel loses mass, it turns to a gas before the next changes through. Some atoms shine blue, when the process is complete, it gives off heat. Extra carbon will glow, red, orange, yellow. The fuel loses mass, it turns to a gas before the next changes through. Some atoms shine blue, when the process is complete, it gives off heat. Extra carbon will glow, red, orange, yellow. The fuel loses mass, it turns to a gas before the next changes through. Some atoms shine blue, when the process is complete, it gives off heat. Extra carbon will glow, red, orange, yellow. Oxidation.